Thank you, Norval. Can everybody hear me?
We can hear.
Well, if Norval can hear, that's good. I appreciate your letting me have a chance to discuss one of my favorite topics with the Blue Ridge section webinar, and that, of course, is risk management. And this is in regard to risk management during product realization. Good afternoon, everybody, or good morning, depending on where you're located. Certain assumptions that I'm making before we get started. I'm assuming that we have people with some experience with risk management and some of the standard tools, that this isn't a brand new topic for you. And also, I am assuming that the interest is primarily on the requirements and expectations for a product that would be on a global as well as a domestic market. I'm assuming also that you're either certified to ISO 9000 or the ISO 13485 for medical devices, or you would be interested in seeking certification. And we are only going to be covering risk management as it regards product realization and not as the activities for risk management that occur after product launch. So without further ado, let's take a look at some of these international standards that are required that relate specifically to risk management. There are a number of them. This is not a comprehensive list. Probably most popular is the ISO 9000, the latest version being the 2015 version for quality management systems. Along with that is a guidance, the 31000 released in 2018 most recently, and that is on principles and guidelines for conducting risk management. There's a medical device standard, 13485, which covers the need to do risk management. ISO 14971 is a specific ISO standard for application of risk management to medical devices. IEC 60601 contains a lot of risk management requirements for medical electrical equipment, and then the IEC 62366 applies to the risk management of human factors or usability engineering for medical devices. As I said, this is not a comprehensive list. There are other standards out there which are incorporating risk management. I see this as a movement that is only going to get more complex and more comprehensive around how to perform risk management. So expect that things are going to change, and they're going to change rapidly. Taking a look at this 13,000 ISO standard, this has been around for a while. The previous version was released in 2009, and it basically talked about this three-part look at risk management, where you are looking at the interface between principles of risk management, the framework, how the process is supposed to work from a management perspective, and then how the process is supposed to be laid out in a flow of activities for actually conducting a risk management on a product. Now, this is what was initially released, but it has changed in this latest 2018 version, which is more systemic It's looking at the system as a whole. It's integrating all these pieces of risk management in a more linked up manner. And in this latest model of risk management, we are now looking at the principles, the things that are intricate in the risk management program as being a very closely related component of the overall framework, the product lifecycle activities, and the process itself of assessing risk, and then utilizing that information to affect product safety, product effectiveness as a part of your risk management program. There's many applications for risk management. We can take a look at risk of a general business perspective, where we can look at the marketing changes, the risks associated with emerging markets or stagnant markets, financial risks, risks from competition. There are operational risks. When you're looking at your own manufacturing site, the operator safety, production overhead, capacity, material sourcing, just as a few examples. Those are risks that also need to be considered in any comprehensive risk management program, but what we're going to focus on today is product risk. The risks around the product itself, how well it's going to do its job for the customer. When you set up a risk management program, there are some basic elements that you will want to have in place. First and foremost, the policy for risk. What is the threshold that the company is willing to accept as far as risk? If you have a clear threshold set, then your decisions for whether or not you can sell a product would be based upon whether, among other things, the risk falls within your acceptable region. If the risk is outside your acceptable region, obviously you need to do something about that. You also need to have a plan. Executing risk management requires forethought. You have to lay out what you're going to do, the tools you're going to use, the responsibilities and their authorities, their roles, what kind of tools you're going to use, how you're going to document the results of your actions. All this needs to be defined in a plan. You also wanted to have some sort of a review process as you go through your development process to evaluate how you measure against your threshold, how well you're performing as the design evolves as far as effectivity of the design and the safety of the product in the hands of the user. There are many tools and metrics that are associated with risk management. You'll need to be able to define which tools and which metrics are appropriate for your company. Training, a very, very important part of a risk management program. People need to have proper training to be effective in conducting risk management activities. You will do best to have a solid program for your training, to use facilitators whenever possible to lead the risk management activities, because they will help keep the teams on task and make the activity much more value added. When you are executing your risk management, you're going to have to document what you're doing, and all those documents need to be filed. A risk management program will have a risk management file to show all the activities that have occurred and so that those records are accessible and maintainable, you will want to be thinking about how that file is structured. Then you will also want to have, after launch, some program for maintaining a view of product safety, product effectiveness, so that you can continue to improve products, feed the information from the customer back into your risk management program. We want to focus on the customer, but we can't forget the bottom line. That is always a part of any program. If you make your products too costly, then the customer is not going to buy them. So the things you want to consider: product safety in the hands of the user, reliability. Is your product state-of-the-art? Does it meet the technology that customers expect to see? Managing development costs can be one of the outputs of your risk management program, focusing on things that are important. Smart utilization of resources, also an output of a good risk management program. Design for manufacturability, alignment with user needs, marketable final product. We need to make a profit. Otherwise, why are we all working? To support the above, you need to have a company-implemented process. You need to define that process through procedures. You need to define that through your policy and the tools that you're going to use to evaluate risk. Not only do you want to have good procedures, but you also want to ensure that you have robust practices. We often get confused about terms that are associated with risk management, and so just to make sure that we're all on the same page, a few key terms here that we should be very conversant with. Risk is a combination of the severity of a potential harm or some negative outcome and the probability that that harm or that negative outcome will occur. Those are the only two components of risk. They can be applied in many different applications, but the severity and the probability are the two things that you will want to measure in order to evaluate what your risk is and whether that risk is acceptable. Harm would be your injury or your undesired consequence that could occur. A hazard is a source of harm. It would be inherent in your product. If you have a product that has mechanical moving parts, then there will be the hazard that those moving parts could cause injury. It's just the nature of the device. Hazardous situation would be the exposure of one or more hazards to the user or to the environment, to something that could get harmed. The risk analysis is a part of your risk process where you're identifying hazards and measuring the severity and the probability of the harm that could arise from those hazards. And last, risk evaluation, determining the acceptability of the risks that you have measured based on the company's risk policy. Risk-based decisions is something that is fairly new. It was exposed in your ISO 9000 in the 2015 release of that standard, where it talks about risk many, many times over, making risk-based decisions. If you count how many times risk shows up in that standard, I believe the number is nearly 50. So obviously, the ISO standard believes that risk is a very important part of your development process. When you are setting up risk-based decisions, you want to set up some method for weighing benefits against risks, because your risk decisions will be to show that when you make a choice, that it will be the most beneficial choice available. You want to gather information about the risks and the benefits that may be affected and involve a cross-sectional team. Many functions provide better information. This is not a one-man job, and you want to make sure you've got the right representation of functions, the right representation of knowledge in making these decisions. You want to document your inputs and the results of your risk-based decision process. And you would use this process not all the time, but when you've got significant decisions, when you are, for instance, selecting a technology or a design configuration, if you need to prioritize tasks, what would be the highest risk things that need the most attention? Allocating budget dollars or resources, qualifying suppliers, for instance. Just a few applications for making risk-based decisions. There are many times during the process development that you are going to be faced with making decisions, and if you can make them risk-based decisions, if you can base them on actual information that would show what the risks are, what the benefits are, that will allow you to make good decisions rather than finding out too late that the decision you made was not well thought out or well understood and was a wrong decision in that case. There's a lot of risk tools that are available. You do not need to use all of the tools available, but there is quite a toolbox that you can select from. Different tools work best under different situations. There is no one tool that does everything well. This list here is not comprehensive, but it is a pretty good representation of most of the tools that are commonly used. There are many references as to how to conduct these tools, and I would recommend you look up information to guide you through the use of the tools. Some are represented by IEC standards, so that you can go to an IEC standard for instance, conducting an FMEA or a fault tree analysis. Others may be in reference books, and I'm sure ASQ has got quite a collection of books that you can use to support your risk management system. The idea being that you want to pick the tool that best fits your situation so that you can weigh the benefits and risks and make wise decisions throughout your development process. What's shown here is a model for design control. This is one of many design control models that are available. The idea here is to show that there are different stages in your process of development and that different tools may be appropriate for different stages of the development. You don't want to wait until your product is designed before you do risk management. You will want to do risk management as early as possible, even at the concept stage of product development. There are risk tools available to start looking at areas that may pose risks in your product performance or product safety that should be applied. And then the process should be an iterative living process as you go through your development process, your process for product development. And the tools that you use at different stages will probably vary depending on how much information you have and the kind of decisions that you need to make. Here's an example of progressive use of tools. Early in the product development, you may use something like a checklist, a what-if kind of list, or a preliminary hazard analysis, a PHA. As you gain more information, as the design begins to gel, fault tree analysis might be a better tool, or risk ranking, or some sort of a risk-based analysis. As you have a design being refined, you're starting to get the fine details. FMEA then comes into play as being a very common workhorse. Risk matrix may be your decision-making tool for determining if the risks are acceptable or not. And then during process design, you may use the FMEA or a HAZOP or a HACCP type of tool for developing your process design. Each of these tools has benefits and negative aspects, so you want to investigate these tools and apply the ones that make the most sense for the application that they would be used in. This is not the only way to use tools. This is just an example, and it may differ with your own product, with your own business. Completeness of risk management is very important. You want to make sure that you don't do half a job. Identifying the risks isn't going to finish the job. You need to determine if my risks are not acceptable, what do I need to do to reduce those risks? What kind of measures can I take to make those risks acceptable? Not all risks are going to be unacceptable, but if I do know ways to reduce the risk that are relatively easy, those are always a good thing to apply. Once you have controls identified, risk reduction measures, they need to be implemented. You need to make sure that they are always going to be there managing the risk of your product. And you also want to verify that they actually do the job they're supposed to. When you have applied your risk mitigation measures, you then can recalculate the risks to see if they are then acceptable. You want to make sure that you don't have unacceptable risks associated with your product. There's lots of tips for doing FMEAs that I've heard from different sources. These are the ones that I find to be very helpful from my own experience. Having a trained facilitator really facilitates that whole process when you're doing an FMEA. It's a complicated process, and people can get off track, especially if this is not something that they do frequently. So having somebody leading the discussion can really economize on your time and your effort. Anytime you do a risk assessment, they tend to be rather painful if they aren't led well. So to make sure that you get the most out of your FMEA, you want to have somebody leading this effort. You also want to be collecting information prior to doing your risk assessment. If you wait until you are sitting around a table before you start discussing about information, it's only going to prolong the process because you're going to have to go out and collect information to do such things as identifying hazards or determining probabilities. Remember, risk is the combination of the probability of some undesired outcome and the severity of that outcome. So you want to have information either about your own product, if you're doing maybe a product redesign, or about similar products prior to the FMEA workshop. Definitely include your subject matter experts, SMEs. Make sure that you have people who actually use the product as part of your risk management process. They are going to have more knowledge than probably anybody else about how things can go wrong. Avoid generalizations. Don't assume that all of your users are going to make the same kind of mistakes or that they all have the same kind of experiences. Data mine. Go look for data. We have a lot of places where there is information from the customer as to problems associated with products. Those are usually readily available if you look either on websites or in technical journals or by looking at societies that deal with specific products from a medical device. In the IVD world, which is where I'm at currently, the American Association of Clinical Chemists is a wonderful source of information about our products. You want to measure severity and probability as independent elements. Don't think that the severity of an outcome can be mitigated by lowering the probability. They are independent elements of risk. You want to select mitigating actions for your specific causes. Those will be most effective in making a reduction in risk that is going to be effective and efficient. You also want to challenge these mitigations to make sure that they will actually work under all conditions. Assuming that a mitigation is going to work without testing it is taking a lot of risk. Also, we don't want to expect the customer to be our test case. We want to make sure that the product in the customer's hands is going to work. We don't want the customer to be telling us how we failed to make a robust design. These are things that I have observed that are problems with some FMEAs, and so this is where I like to focus when I am facilitating an FMEA process. Risk management is and is not. A risk management process is planned, it's not improvised. It is intended to be proactive, not reactive. It's used in the predictive mode. You're predicting what could happen. It's not a crystal ball, so you are not always going to be 100% correct. It is a potential problem finder. It is not for implementing corrections. It's to support decisions. It is not the source of all your answers. It's an iterative process, not a once and done. It is intended for product improvement. It is not a rationale for status quo. You want to use the right tool for the situation. It is not one tool for all situations. And it is to have a predetermined threshold for accepting risk, not flexible criteria to line up with expectations. Key to a really robust risk management process is going to be top management. If your top management supports the risk management process, then that is one giant step to having an effective risk management program. The top management requirements would be to have an eye on the program on a continuing basis. You want to have a view of the effectiveness of your risk management process reevaluated periodically to make sure it's doing what the business needs to have done, that it is effective, it's efficient, that you have a clear risk policy that reflects the business threshold for risk. It also needs to have timely implementation of new requirements. I mentioned that these ISO standards are coming out now with more risk management requirements embedded in them. As these new requirements become a requirement for your business, you want to make sure that those get implemented into your risk management system, into your quality management system procedures. There should be adequate allowance for the resources to execute risk management. And that includes making sure that your project timelines and budgets allow for the activities that are necessary for a good risk management program. Top management should also make sure that there's training available for people who have to participate in risk management. Provision of those training programs is one of the key things that a good risk management process must have for good execution. And reinforcement of compliance to QMS procedures will ensure that your risk management program is going to be successful. That is, if you have good procedures but poor practices, that is not going to be effective. You need to make sure that management is following the procedures that you have implemented for conducting risk management activities. So, are you ready for realization? Risk management is not just one activity, it's a series of activities that need to all be completed prior to releasing a new product into the market. Completion includes execution of an approved plan, formal records that support that the plan is effectively executed, the records, of course, being part of your risk management file, conducting a final evaluation of your product risk to conclude that the product is acceptable and will not cause the customer undue safety or performance issues, confirming that the suitable controls are in place from a manufacturing process to ensure that a strong design is not compromised by a poor process, and summarizing all these risk management activities and outcomes in a risk management report that supports product acceptability. So in summary, you want effective risk management led by knowledgeable top management. Top management is key to a successful risk management program. The process is iterative. It is a living process. It's not a one-and-done process. Risk is composed of two components. Don't make the risk assessment process complicated by adding other things. If you can measure the severity and the probability of risk, that is all you need to determine if risk is going to be acceptable or not. You need to involve the right people. It's not a one-person activity. It involves an interactive group from different perspectives to really thresh out the hazards and the corrective actions that need to be put in place to keep your products at a safe and effective level. Risk decision criteria needs to be defined up front. It's not something that's flexible where you say, well, I know it doesn't meet our criteria, but we need to get the product out anyway. That's not the way a good risk management program works. Plan ahead. Don't wait till the end of the project to do your risk management, and complete the evaluation of your mitigations and controls. Make sure the controls are going to be in place, that they are going to work, and that they don't create new risks. So, at this point, if there are any questions, I'm willing to entertain those.
Okay, thanks very much, Barb. We're going to go start working through the questions here. First one we have, in defining risk, you state that it's the combination of severity and probability of harm. In FMEA, we also consider likelihood of detection when a harm does occur. How does risk management consider this?
Detection should be a part of your mitigation process. If you are able to know that a problem exists, it doesn't reduce the risk unless there is some activity taken along with observing that risk is there that would reduce the risk. Let's take, for example, if I have a kitchen fire. I can see that there is a fire, but I have many options available to me to do something. I have not reduced the risk of that fire any just by knowing it's there. If I were to throw water on a fire and it was an oil fire, that would be a wrong thing to do, and that would increase my risk, not reduce it. So I have to be careful that along with observing or detecting some sort of risk, that I have the right action associated with it in order to cause a reduction in risk. I know that we like to have detection in our risk assessments, and if that detection is a part of a control where I detect it and then I respond in a certain way, then that is a very nice addition to your risk assessment. But recognize that just seeing that there is a problem and not having something defined to do when that problem occurs is not going to reduce your risk.
Okay, thanks. Before we go too much further here, I'd like everybody to take a look at the chat box real quickly. I private messaged one person just to get their last name, just so that we can account for you on the registration list. So if you could take a quick look and answer the private chat that we sent, we'd appreciate that. Let's go on ahead here to the next question. At what level should a risk management plan be signed off?
A risk management plan is something that should reflect the requirements of the business. Signing a risk plan off by the team that's going to execute the risk activities is probably not appropriate. I like to see management take ownership of a risk plan. They should be the ones who are going to be responsible for the outcome of that plan, so they should be involved in approving the plan prior to risk management being executed.
Okay, moving on here to the next question. Everybody will consider a risk that impacts themselves as a high priority. Is it necessary to involve senior management for managing risks, since they are more aware of the big picture and resources available to address each risk?
It would depend on what kind of risks you're looking at. If you're looking at business risks, you definitely want to be involving upper management, because they would be very strongly impacted by the consequences. If you're looking at product risks, they would probably be more interested in the overall outcome of your risk management program than the specific risks that you would be evaluating in your risk assessment process. So I would say that upper management needs to have input at the beginning of the risk program with your plan, and then at the end of your program where you've evaluated the risks according to the plan to see what the outcome is, but probably not necessary if you're looking at intermediate kind of activities, unless they had specific knowledge that would be important to contribute. Again, they've set the criteria in the plan, and as long as you're following the plan, you are going to be meeting the business expectations.
Okay, moving on to the next question. Is risk velocity typically considered?
I'm not certain what you mean by risk velocity. If I could get a little clearer understanding of what that is intended to be.
Duke, could you clarify that? Okay. Velocity is how soon or fast the impact will occur.
Oh, okay. Yes, if that is important to the benefit or risk of the risk, the benefit being that sooner is better, then you would definitely have to include that in your risk evaluation process. If the impact is something that is not important, then of course you would not want to include it in your risk management process because it adds a level of complexity. Again, it depends on what kind of risk you're talking about.
Okay, we're going to move on to the next question we have. Should there be an element to learn from what is planned versus what actually happened?
Yes, that would be after your product is released, your post-market process for risk management would continue to collect information to determine if your estimates are accurate or not. As we are in product development, there's no way to know exactly what the customer is going to do with the product. There's no way to know for certain how often things are going to break or how often problems are going to arise. You do the best you can in estimating these, but you're really never going to know until product is in the hands of the customer. And at that point, you, in your risk management program, continue to collect information and update your risk assessments with this new information.
Okay, next question is, since the plan is living, when can you say a plan is final and senior management no longer needs to be closely involved in the process?
When the product is no longer available in the market, that's when upper management no longer needs to be included in the process. It's a situation where, especially in the medical device world, the products that are made available for physicians, clinicians, hospitals, whatever, can evolve in their usage over the life of the product. And so you have new risks coming in because of new ways that a product is utilized. So there is never any endpoint where there's no new development of uses. And because of that, your risks are going to constantly change. Technology is going to change. Expectations of the customer is going to change. So your criteria for what's acceptable is likely going to change over the life of the product. So there, as I mentioned, there's no endpoint to when upper management should be involved, and there's no endpoint to the risk plan until the product is no longer available.
Okay, moving right along here, the next question is, could you explain some of the acronyms such as FTA and FMECA?
Sure. FTA is fault tree analysis. This is a top-down tool that starts with the end result as a top element, and then it evolves from that the potential sources of activities or causes that could lead to that top event. It is a tool that is used for developing the sequence of events that can lead to a harmful outcome, assuming that it isn't just a one-time event. Let's take, for instance, I like to use the example of having somebody slip and fall, and the reason somebody could slip and fall is because there's something slippery on the floor, and there's something slippery on the floor because somebody spilled something, and there's somebody spilled something because the container that they were using was not adequate for whatever they were, whatever it was that they were carrying around. So all these things lead to the fact that somebody has an accident. Any one of these events then is displayed in your fault tree in a descending order down to a root cause. It's a very visual tool, and it is a very effective tool for identifying sequences of events that could lead from a hazard to a final harm. Now, the FMEA is the Failure Modes and Effects Analysis. It's what's called a bottom-up tool. The FMEA starts with a component or an element of a product design and then determines all the ways that it could fail to perform, all the things that could go wrong with that element. So it's a bottom-up approach, starting with kind of the component and then expanding to all the different failure modes that could be associated with that component not doing its job. It's a different way of looking at things, another effective tool, but a very different type of tool than a fault tree analysis. I don't know if there's others of those that you also want to have developed. These can all be found, if you want, in the risk tool references. ASQ has available many of those, or you can look it up on the internet. These are all basic common acronyms for tools that are used for risk management. If there's anything in particular that I haven't covered, let me know, and I'll talk about that too.
Okay, we're going to move on to the next question here. Since a type of risk is competition, how to prioritize something like this since it may never come to be?
That's where it becomes very important to make sure that you understand the probability of occurrence. Sometimes that's going to be a very difficult thing to predict. And if you couple that with the severity of the outcome, how critical or how serious a bad outcome would be, that is something that can be used to prioritize whether it's an event that you even want to bother evaluating the risk on. If the outcome could be very minor, why spend a lot of time on it? If the outcome could be a really serious, critical impact, then whether or not the probability is high or low, you still probably want to evaluate what the risk is, and if there are things that could be put in place to mitigate that risk.
Okay, we're going to move on to the next question here. What is the expectation of ISO 13485-2016 on the application of risk-based approach on the processes needed for the QMS?
The risk-based approach is kind of a generic way of looking at making sure that what you're doing has benefits outweighing risks. And this process that you want to put in place for making decisions about what the benefits and risks are should be a formal program, so that you have a consistent way of approaching decisions that would be based on risk. If, for instance, you are looking at suppliers and you want to evaluate your suppliers, not all suppliers provide equally critical components. A supplier that supplies a critical component you would want to have more scrutiny over that supplier to make sure that they have good systems in place for consistent product manufacturing. You would also maybe want to consider risks of supply. If a supplier is in a flood zone and periodically the supplier gets flooded out, that could seriously impact your supply of parts. So you would consider the risks associated with the supplier, both from a supply consistency and a product quality perspective, perhaps, and then apply the appropriate kinds of controls to reduce risks that would be unacceptable, or making decisions around which suppliers to use based upon the risk associated with each of those suppliers.
Okay, we don't have any other questions showing up here. We do have time, I think, for one more question. So if you do have a question in mind that you would like to ask, please do go ahead and do that. In the meantime, I'll take a moment here to remind everyone that next Wednesday, June the 13th, will be our next webinar. It'll be Function-Based Resiliency with J.D. Solomon of Jacobs. There is still opportunity to register for that one. Please do so through Eventbrite if you are interested. Let's see if we have any other questions. We're not seeing any other questions come up here, and we are at the top of the hour. We are going to take an opportunity once again to thank Barbara Young for presenting for us today.
I appreciate it very much for the opportunity.
And we'd also like to thank all of you for joining us today as well. And we look forward for seeing many of you hopefully next Wednesday. Until then, we'd like to wish everybody a good rest of the day. Thanks again. Bye now.